as I explained, so sine pi on 2 will equals to 1. And cosine, well, I will go next page later. Cosine 0 equals to 1. Okay, if I want to achieve max or minimum, is this thing can change between, well, that's values in between. Value can change in between -1 to 1. So, well, it's definitely, I can either use 1 or -1. If I use the value point something in between, that definitely reduce the number. Okay, reduce the number. So I want the max. I want to achieve the extreme value. So that's why I want to make the bracket, the sine whole bracket equals to pi on 2. And then, okay, I will just do that first. For example, this one. In the bracket, I have 2 bracket t minus pi on 4. So 2 bracket t minus pi on 4. If you really don't get why I should use pi on 2, just remember, when you sketch, you make the whole bracket for sine equals to pi on 2 and solve for the t. So that equals to pi on 2. And that's pi on 4. And that t equals to pi on 2. Okay, this t will do what? Will make the sine become 1. Right? Make the sine become 1. Okay. But there's still chance it can be a maximum or a minimum. So you need to decide. So you can think, okay, this t can make the whole sine become 1. So 1 times 3 plus 2, y equals to 5, which is the max. Okay, y equals to 5, which is the max. Okay, what I want to say is, if a is greater than 0, you will achieve max. If a is less than 0, you will achieve the minimum. But you always make the bracket equals to pi on 2 and solve for t. That t value can give you max, can give you minimum. Depends on the a value. Okay, depends on the a value. So if a is max greater than 0, you will have the max. If a is less than 0, you have the minimum. Yes?
So this value that we got, t equals pi on 2, that's an absolute value.
Which one? That one?
Yeah.
Why absolute? Whatever you solve out, just that. You just solve.
Could be a minimum or a maximum.
Oh, okay, that's the y value. Like y can be 5 or -1.
Oh. Right.
It depends on the a. It depends on the a. If a is positive, you have 5. If a is negative, you have the -1. It depends on a. So this one is purely depend on what you have solved out. You solve out t equals to that. That t is the extreme value. So I have this point here, pi on 2 and 5. Okay, this is my value here. Okay. Well, it's whether max or minimum. When you solve the sine bracket equals to pi on 2 and solve for t, you definitely solve out max or minimum. Okay, it's for sure. Whether it's max or minimum depends on a value. If a is negative, you have the minimum. If a is greater than 0, you have the maximum. After you find this point is so important because you can predict all the point after that. So what is your step size? Your step size is a pi on 4. Okay? When your horizontal travel pi on 4, which achieve here, the height will move to the middle. So you have the next point here. Okay, so I start from this point. Horizontal move pi on 4, we have here. And move another pi on 4, I will get the minimum. And move another pi on 4, will back to the middle. Okay, just count the box, okay? Move horizontal this much, your y value will move the line, one line below or one line above, according to the pattern. Let's have a look at the period. Well, period asks us to sketch from pi on 4 to 5 pi on 4. So, well, 5 pi on 4 I already reached. I haven't sketched for pi on 4 yet. So to sketch for pi on 4, well, it's another unit move to the left. So the highest point will move to the middle. So I have put all this dot here. Okay, you can see all this pink dot here. Then I can complete my graph. Yes?
Why does it start at 5?
Domain given. Domain given, pi on 4, 5, pi on 4. So I need to sketch to that point or beyond that point. Okay, be careful with your curve shape. Okay, this line to this line is not a straight curve. Okay, it's not a straight line. It's okay, first like this way, and the next one is to this way. Okay, see the difference? It's like a twist, like this way and then this way. It's not a straight line here. It's not like a straight line like this or this. It's like actually two part. It's actually two part. It's decreasing first and then further decreasing. Okay, and I know this point is 5 pi over 4 comma 2. This max is pi on 2 comma 5. That's the point you start. Okay, that's the point you start. And the end point is pi on 2 comma 2 as well. And you label the minimum. That's pi negative 1. Okay, I have complete the graph. Okay, I have complete the graph. Well, there are also x-intercept here, but I don't know how to solve it yet, so we'll wait to tomorrow lesson to solve for x-intercept. Have a think about what we have done overall, okay? Yes?
Does it matter if you like continue drawing the graph?
Yeah, you can't because domain is restricted. If you keep going with the graph, then you will lose mark. If the domain is not given, you can sketch anything. Yes? They will give you the domain. It's because the graph continuously going forever. If they not give you the domain, there's no way to sketch it. Okay, everyone. Any questions? Because I want to start the next one for the cosine one for a little bit. I definitely can't finish everything, but I want to start with it. First of all, any questions for this graph? How I sketch this graph? Any questions? Okay. If you don't have any questions, go to page 11. Okay, I'm not sure if you can you see the small box clearly, like the scale? Can you see that on your printing? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, count 12 box and give a pi. 12. You should have 2 on your right. Okay, you can count from the right hand side. So count 2 and give a pi. So that's a 12 box in between. So I have 14 box in total for the right hand side. So give a pi. So the thing is, each box is a pi on 12. Okay, each box is a pi on 12. Well, I just labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's 1 pi over 12, 2 pi over 12, like this. Okay, so that's just 12 box. It's easy for me to sketch later. And for the vertical, I just label 1, 2, 3, 4, and negative 1. Okay, now decide, where's my middle? Or what's the first thing we should do? Mean is what? Middle line is which value? 1. Okay. Okay, what's the amplitude? 2. So what's the max? 3. Okay, what's the minimum? Negative 1. Good. Okay, so I have 3 lines here. Okay, the question asked me to sketch in between 0 to pi. Okay, to sketch in between 0 to pi. That's 0 pi on 12 to 12 pi on 12, okay? Because I have unit of 12, so 0 pi on 12 and 12 pi on 12. Okay, what's the next step we'll do? Period, good. What's the period? 2 pi? Pi. 2 pi over 2, which is pi. What's the next step? Yes, step size or step length. Each step takes how long? What's each step? Pi on 4. Okay, pi on 4. Okay, because I have everything on denominator of 12, I just make a denominator 12 for this one. It's just easy for me to see how many boxes I should move. So that's 3 pi on 12. For each step move, you need to move 3 boxes. Okay, for each step, you need to go right or left for 3 boxes. Okay, what's the next thing we should do? Values? Okay, so what I should do for values? 2x minus that equals to 0. Yes, we're doing for cosine, so the angle must become 0. Okay, the angle must become 0. Okay, easily to solve that, we have x equals to pi on 3. Okay, again, because it's denominator of 12, I make 4 pi over 12 here to see how many boxes I should have. Okay, do I have a maximum or a minimum for this one? Maximum, because a is 2, which is positive. So y should equals to 3. Okay, should have 3. So I have 4 pi over 12, comma 3, which start from here. Okay, 4 pi over 12, and start from here. Okay, I can move to, well, each step needs to move 3 boxes because it's 3 pi on 12, each step. So I move 3 boxes, move to 7, and then the point will move to here. And move another 3, which get 10 to 10. Then the point will move here. Okay, now the tricky thing happened. Can I see 11, 12 pi? I also move 3, that will reach 13 pi, which is out of the domain. So what I will do is not just on the domain. The last point is just not on the domain. So what I will do is I will go beyond than the domain a little bit to see the shape first. So, well, 10 plus 3 will be 13, which is here. So we have a point here, but this point I shouldn't sketch it because it's out of the domain already. But let's put it there to see the shape and then to find the endpoints after that. Okay, we start from go for the right, but don't forget we have left as well. So 4 minus 3, we have 1. 1 will back to the middle. Still not reaching the domain 0 yet. I need to further move 3 units. I know it's beyond the domain, but I will sketch it. So I move further 3 units to the left. I have negative 2. So I will have the minimum here. Okay. You know we have endpoints, right? We need to evaluate endpoints as well. Okay, we need to evaluate endpoint as well. So what I will do is, I see when x equals to 0, what my y value equals to. So I make x equals to 0 to find the point. Y equals to 2 cos 2, 0 minus pi on 3, and plus 1. Okay, solve for this. Okay, solve for this. So what I have here is y equals to 2 cosine negative 2 pi over 3. and then plus 1. Okay, 0 minus pi on 3 is negative pi on 3 times 2 is negative 2 pi on 3. Question, where is negative 2 pi on 3? Which quadrant? Third. Okay, this is negative pi. Okay, this is negative pi. But negative 2 pi on 3 is negative pi plus pi on 3. So I will have point here. Okay, and then the reference angle will be pi on 3. It's not reaching negative pi yet. Compared to negative pi, we missed pi on 3. So 60 degrees, that's why it must be in the third quadrant. Okay, T quadrant. T quadrant. If it's T quadrant, y will be negative 2 cosine pi on 3 plus 1. Okay, we change the value to reference angle and we decide it's a negative, so we put the negative sign on that. Next question, what's cosine pi on 3? Half. So negative 2 times half plus 1. We have 0 here. Okay, so we have 0, 0 for the endpoint. Okay, we have 0, 0 for the endpoint. So I have a point here. Okay, I can see the pattern. Okay, I can see it's right. It's approximately here. Careful at 0, 0. Okay, now I will sub when x equals to pi. When x equals to pi, y equals to 2 cosine 2 bracket pi minus pi on 3 plus 1. Sub x to pi. Okay, I will do an interesting thing here. I will expand the bracket. That's 2 pi minus 2 pi over 3 plus 1. Okay, just expand the bracket. Why I expand bracket? Because I see 2 pi here. I see 2 pi here. I know like we love 2 pi because we can just ignore that. That's the same as this one. You add 2 pi is the same as you don't add this 2 pi. Because negative 2 pi over 3 adding 2 pi, it can be said it's just negative 2 pi over 3. Okay, why I love this? Because it's back to this question here. Okay, it's exactly the same. That's 2 cosine minus 2 pi over 3 plus 1 is the same as this one. Okay, I'll connect it here. So that is just equals to 0. That's the same calculation as before. That equals to 0. So pi 0. The right hand side endpoint is pi 0. I have a point here. Pi endpoint. Both endpoint. You have 0 and pi is the domain. Yeah, right hand side and left hand side endpoint. Have 2 endpoints. Okay, now we can complete the pattern like it's very easy pattern. Well, see, for this side, it's not really the graph you should sketch. So we have this graph, but like I showed dot lines here, it's not really belongs to your graph. And then keep moving this way. Move down. Move further. Okay, here you shouldn't have graph. Start from pi, you have graph. See the dot line, you don't need to sketch them because it's not really part of your graph. It's beyond the domain. Why I do it? Because I want to see the shape. It can make a better shape for me. So I can label that's pi comma 0. That is 0 comma 0. Also, I should have maximum. That's 4 pi over 12. That's a pi on 3 comma 3. And this one is 10 pi over 12, which is 5 pi on 6, comma, -1. 10 pi on 12, which is 5 pi on 6, and -1. Label the max, label the minimum, label the endpoint. We also have one more x-intercept here. We can solve that tomorrow because we'll learn how to solve circular function equations. So I have the point here. Actually, if you sketch graph, you better should solve the x-intercept first and label it at the correct place and then complete the whole chain of your graph. But like we haven't learned that yet, so that's why we just roughly sketch the graph. And tomorrow see if we kind of have a quite accurate x-intercept. We should have a quite accurate x-intercept if your graph looks exactly like as mine, so x-intercept should be fine. Okay, that's my cosine graph. Sine and cosine do exactly the same thing, only difference is when you decide the angles. Okay, one angle equals to pi/2, the other angle equals to 0. And that's all we'll do for today. Any questions? I know you learned a lot and I squeezed a lot of things together today. If you have any questions, feel free to ask. Middle? No. Unless they ask you to label it. Otherwise, no.
Can you actually roll that to be -0?
Yeah, you can. That's fine. Any other questions? Well, when you sketch the 3 lines, what you do is you better label this graph as y equals to sine x, like label the graph like this is the graph I want, and then it will be right. The equation. The equation y equals to 3x sine x, what? Any other questions? If you don't have any question today go back to revise, and tomorrow start of the lesson. If you have questions, ask me first, and then we go to the new content.